Okay, we are live. Let's start our speedrun application. We start by giving a bit of context. This is from last time. This is what we got from last time, where we have a simple platform and our player, we can jump, but we can jump forever and we can jump in the air. At least we have some kind of collision. The issue is that when I move the window, the collision stops working. This is where we stopped at last time. What we will do today is we will focus only on this world generation. We'll ignore the player physics and movement, etc. We'll focus only on world generation. And I also in the past 2 days I found a lot of cool stuff. For example, this debug program that allows me to see what is happening in OpenGL. And here, the issue with the collision that stopped working, this application allows me to see every frame of the game. And here we can see that in most frames, my player is looking like this. He is not like this perfectly. Look at how he's jittering. It's because most frames he's like this. And when I move the window, probably I have stopped him at one of these frames, and on an update he moves once again downwards and then checks for collision, but he's not colliding with the floor anymore. So this application is really cool. Here is another one where I can see my triangle and its and its values. It's super cool application. I even went through this tutorial, like these videos for making a 2D game. I went through 14 out of like 60 videos, and a lot of cool things for 2D making a 2D game, like batch rendering. Because one interesting thing is that here, what I wondered for a lot of time was how this little game, look at how much it's taking up. Like my little game is taking up 5 or 6% of my CPU, which for my CPU is a lot if it takes up so much. And I was wondering, why is it like that? Because I only have few squares on the screen. The issue is of my draw calls. So this is one rectangle, this is one square, another square, and for each one of these squares, I am doing a draw call. And draw calls are expensive. And what we will do today, what we have to do, because we will render a lot of squares, like 10,000 of them probably, we'll render a lot of squares. In order to be optimized, we have to draw them once or as few times, to have as few draw calls as possible. And this is what I gathered from this video, batch rendering. We'll render the squares at the same time. And also for the camera, I was wondering how to do the camera. And here there was a video that mentioned about the camera. So about the camera, yeah, when we get there, we'll go through it. Now, let's move on to spawning 10,000 squares. Now, 10,000 squares, we will not be able to look at all of them, probably, until we have the camera and until we can move around. So let's start with cleaning up our project. We'll start by cleaning up some things, and we will not need the player. We will delete the player. Let me check git status. Git. I'll fix this commit later. Oh, it's on track file. Okay. Let's delete this player. We will not need the player. And okay, this is how we render each block. We'll leave it for now. For each block, we just create a VO. We create a VO, a VBO, and we don't even use an EBO. We load a texture and that's it. And when we draw it, we have a matrix that we use for each block, because I thought that for moving a block, instead of having to change its vertices, we can just multiply it by a matrix. But when we batch render most of the blocks, this may be not possible. I have a way that we can still do this, but it will be not as easy as without batch rendering. Collisions we don't need. And process input, we will remove player movement. We'll remove player movement. Delete this. And delete this. And here we can make, like, if the escape key is pressed, to terminate, to close the window, but we have to check how did we close the window. Close program like this. Okay, by pressing escape, we close the window, and this is again for collisions. I want to simplify the code. This is our vertex and fragment shader. Again, the shader. Here is our player. Here we create 20 blocks. And what else? This is our projection matrix, which we will use. But in addition to a projection matrix, we'll create a camera. The camera is something new I learned recently. Yeah, this is the projection matrix. And here we will not check for collisions. We will not draw the player. And for processing input, this is it. Let's start the game. And now we just have the blocks. Okay, you know what we can try? We can try as it is now to render 10,000 blocks. Let's see as it is now how it is to render 10,000 blocks. Where did we render? Here, block count. We'll change it. Let's change it first to, let's first see how much. Oh, you know what? Another thing I learned recently is how to get the FPS. The FPS, std, cout, FPS, and it was like 1 divided by delta time. And line std, yeah, I think this is how we calculate FPS. Let's run the program and look at it. FPS is around 160 currently. FPS around 160. Let's now see how much the FPS will be when we render 1000 triangles, squares. 1000 squares. Let's test it out. Now we cannot see them. We cannot see them. Let's change their size. Because I think I'm wondering if it does optimizations when it's outside of the screen and ruins our experiment. So first let's, where do we create the blocks? Here. And so it's X, Y, and then size. So this is X, Y, and then size. Size, we will have it as 10, so we can have more on one spot. And I'll have them start from more to the left, just so we can fit more on the screen. Look at all these squares. But still we have a lot of FPS. Let's... how can we fit more of them on the screen? Let's have them each to be of 1 unit of size. Let's have them be 1 unit of size. And here they are. These are just a small line of 1000 squares. Now let's increase them to 10,000. Oh my. So 10,000 squares is running at 40 FPS. At 40 FPS, and the game is still using about 5% of CPU. Can I fit them all on screen? Okay, I can. Let's increase their size to 10, but still have them really close to each other. I want them to be more in the screen. Maybe it's doing some optimizations. Let's not even move them. Let's not even move them. Let's have them one on top of each other. I want to see if there is value in batch rendering for my use case right now. Okay, let's render 10,000. Let's render 50,000. Let's render 50,000. This is 50,000 draw calls. Look at how much it cannot even start the game. Performance. It's currently at 8 FPS. 8 frames per second. It's currently at 8 frames per second. The GPU is not used that much. My game. GPU usage is not that much. OBS is using. Okay, so do we make do we use do we need to use batch rendering? Like here, how many squares would we need for the world generation? Is what I'm wondering. I'm wondering. We can try. We can try doing it without batch rendering, and to see do we really need it. Yeah, we can try without batch rendering. Probably we can try. Let me increase the font, and let's okay, we can spawn 10 and here by 10,000 squares. I don't mean just spawning 10,000 squares one on top of each other. We will need to spawn them as like they're spawned in Terraria. But before that, we'll just spawn them row by row without any terrain generation. And on noise, on the noise goal, that's when we'll have terrain generation. No, we'll need sprite. We'll need to batch them together. Like, it's too slow. We'll need to render them together. And I think that's our focus for now. To spawn a lot of squares with good frame rate. So right now the frame rate is around 8. I want the frame rate to be like 60 plus, spawning 50,000 squares. Look at it, it cannot even start the application. Okay. Yeah, it's struggling. We need to render them together. What do I mean by this? Look at how for each square, here this is, I'm calling them blocks. For each block, when we draw them, we call the draw function, and in the draw function, we have this GL draw arrays in here. This draw call is our expensive part, and we're calling this function 50,000 times. We need to call this as few times as possible. How can we achieve this? Well, currently, when we create a block, we create its vertices. We create its vertices and we send them to the VBO. We send them to the VBO with this function. Once we've sent them to the VBO, when we say draw, we draw on the screen just these vertices that we have sent. And what he did in this batch rendering tutorial, that's 44 minutes long, what he did in this video, I've took down notes, is that he filled this vertices array with all of the blocks. Like, not all of them, he has 1000 blocks per batch. So he filled all the vertices here instead of just one block. He fills the array with as many blocks as he can fill in here. That's how he does it. And then when he says render, when he says draw arrays, he's drawing all of them at once. That's what he's doing. And he's also using indices. Indices, what I mean by that is here I have 6 vertices. I have 6 vertices where some of them repeat, like this one and this one repeats. This one repeats as well. So we can remove 2 from these vertices. They'll become 4. And this way we send less data. And now for each vertex I'm sending little data, only 4 floats. But when we add textures, when we add probably even more data on each vertex, and when we have 50,000 of them, this repetition is not okay. So we'll also use EBOs and indices. We'll have, instead of 50,000 by 6 by 4, we'll have 50,000 by 4 by 4 float values to send. So instead of blocks, we'll create another class. We'll call it class batch render, I think. What else? Batch rendering. And we have our batch rendering. And how will it be used? It can have an array of game objects. And that's the other thing. He doesn't have a class block, class player. He has a class game object. And he's using this entity component system. Like, yeah, he has a video. Here it is. Entity component system. Where he goes through architectures of games, different ones. And the first one he started with is object-oriented approach, where it has a big hierarchy. But there are better versions. Here is a better pattern. It's the component pattern, where you have a game object. You have a game object, and a game object has a list of components, and a component can be the sprite, collider, font, etc. This way easier to work with. And he also mentioned other ways of doing it. And here, entity component system. This is an even better approach. But we'll maybe try a simpler one like this component pattern. But before that, should we create game object right now? Or we can keep it simple as just having a block. How can we do this? We can set a limiter int batch size, and let's set it as 1000. So each batch it could be render batch. So each render batch will, when we call, our goal will be when we set the draw arrays, when we call the draw arrays functions, to draw at least 1000 squares at the same time. To draw 1000 squares at the same time. That's our batch size, because I think we cannot render more than that in one draw call, but we'll experiment. It's easy to experiment. Now, what else do we need? We need, now, should this be a vector? Like a vector of block blocks. These are our blocks to render. Yeah, these are blocks to render. And here for our blocks, we will not, we'll delete the draw function, but we'll keep it for now just so we can have our syntax to be at hand. So for batch renderer, we need, let's create a constructor. Let's create a constructor. Now, how will we do this? At the start, there we have no block set. That's fine, but we need to set the VBO. Okay, so we need, we need here assigned int VAO. We need one VAO, and we need this time reference to the VBO, vertex buffer object. We need reference to the vertex buffer object. Here, notice how for each block before, we just kept track of the VO reference, the vertex array object. I think that's what it's abbreviation for. We kept reference only for that and ignored the VBO because we only need it when we draw the block. We only needed to bind the VO, and that's it. But here, for the render batch, we need reference to the VBO as well, because we will be changing it. Here at the start, we'll be creating an empty vertex buffer object. It will be empty, and when we add blocks, we'll be changing it. That's why we need to keep its reference. That's why we need to keep its reference. So at the start, let's create, we'll also need an EBO, which will be kept the same. So now, let's copy from here downwards and go in our render batch, and let's go inside our render batch. Hello. Hello. Hello, Quilio Manar. I'm just making Terraria world generation. At least I'm attempting it. I'm attempting to do that. Now, for when we for the default constructor of the render batch, we create the VO, we create the VBO, and here for GL buffer data, where we give the VBO its vertices, this time we won't be doing that. But I want to see GL buffer data and what other functions we can use. It's not set in here. We can check. We can check where's my browser window. So it's gel buffer data. I want to see there was another call of this function, gel buffer data, where we don't give our vertices. So this one is target, size, data, and how we'll be using it. Gel buffer, is it just gel buffer? Gel buffer. Which function did he use? I think it was just the same function, but it had like here batch rendering. And without verse here it was. And yeah, look at it. Look at it how it is for him. Is gel bind buffer? No, not bind buffer, the other one. Here look at how he has size, and that's it. Just the size. That's what I'm looking for. Here is the same function, gel buffer data, and he just sets that it's for the VBO, and here just oh, he has the vertices array. Yeah, we'll also need that as well. But for me, in C++, it's not giving me that function as an option. Here, let me remove this. Do I have it? No, I don't have it. Let's see, gel buffer. Address range, touch memory, subdata. Address range? No, it's not that. Gel buffer, storage, target, size data, no. Let's check. This function is really important for our batch rendering. So that's why we'll search for it. Gel buffer data, just size. Now, what does he use afterwards? So here he just gives the size, but if the array is empty, can't we just use that? That's what I want to see. So this is the start, and this is the start. This is where we add each one. Rendering. Yeah, rendering is what I want to see. No, this is renderer. I want to see when he calls this function again. Oh, sorry, the changes in the camera changed. I have to stand up. Yeah. Let me fix the mic. Okay. So let's see. Let's see now. Here. Vertices length. Okay. I think here he does it. He's binding it. No. VBOID. No, this is the first time. Yeah, the length and bytes. Okay. This is his first call. GL buffer subdata. GL bind buffer. Okay, GL buffer subdata. He's changing it. Yeah, you know what? That's what we'll do. We'll call. Where is it? Now here, let's have. Let me. Yeah, we will call the. Let me fix the chats. Now we will call. First, we'll make our vertices array. Here like this, our float array of vertices. We'll paste it here and it will be empty. It will be empty, but can we do this? Incomplete type. Oh, you know what? I think it has to be. Man, I'm so bad with C++. Incomplete type float. Float. Oh my god. Let's see. CPP array field. Let's quickly look at the reference. Yeah, okay. Man, what? If it's 1 and we have one value here, it works. Yeah, okay. But if it's 0, if it's 0, it doesn't work. Oh, you know what? It has to be actually batch size times 4. Yeah, batch size times 4. But if it's like this, non-static member reference must be relative to specific object. Um, hmm, the amount of vertices, or we can, like, I think the problem here is that here it has to be, like, this can, it has to be the same size. Like, it has to be size that doesn't change. So we'll maybe make it, I'm hearing audio from somewhere. I'm hearing audio. Yeah, it's from Twitch. Okay. It's from Twitch. Now, here, if I do it like this, it will work. But the problem is I'm using just a variable. I think I'll keep it like this for now and we'll change it. So this is 1000 squares, and each square will have 4. Oh, you know what? It's actually 1000 and 1000 squares. Each square has 4 vertices because we'll use an EBO, and each vertex will have I think 4 values. 4 values. We'll leave it like that. And here, where we assigned in VBO, gen buffer, bind buffer. Where's our function for giving the for setting the VBO? Yeah, buffer data. So here, bind buffer, after we bind it, yeah, we set the data, and the data, yeah, the issue is that this will not be empty, I think. Yeah, it's not an issue. It's not an issue. Yeah, I'll leave it like that. So what we're giving here when we create the render batch, we're not giving it any vertices. We're just creating the VBO, and we're setting we're initializing its values. And here for static draw, it will be dynamic. Dynamic draw. It will be dynamic draw, and here this will be the same. This will be the same. So generally, what we're doing right now is we're doing the same thing as we did here for each block, where when we render a block, we create a VO, VBO, we have our vertices. The difference is that inside our vertices, it's not just for one block, it will be for 1000 blocks. We'll fill the vertices with 1000 blocks. Now, okay. And when we initialize a render batch, we have no blocks here. We have no blocks here, and that's why the vertices are empty. But we're just setting its size, and we're configuring it, setting how it will be read. So here, we're saying that the first two, for each vertex has 4 floats. The first 2 will be the position, the other 2 will be the color. That's what we're setting here. Yeah. We also need 2 more for texture coordinates, but we'll keep it simple for now until we see that it works. What else? What else? We need an EBO as well. We for sure need an EBO, but we haven't used one. So I have to check. Let's check our reference here. And here, texture, drawing. Do we have EBOs here? Yeah. Draw triangle. EBO. Create element buffer object. That's what we need. Here, let's create element buffer object. So here is our, this is all for our VBO. And this is our element buffer object. This is our element buffer object, and yeah, we need our indices, but we have to create our indices. Now let's open a whiteboard. No, not a whiteboard. Let's actually we will use some cool sites. Excalibur. Share bowling. I'm trying to open Excalibur. But how can I? Like this, I have some math stuff here, but I want to open a new one. Save. We can just work here. Doesn't matter. Okay. Now for EBOs. Now when we render a triangle, why is this green? Here and this. When we render a square, we have a vertex here, and here, 4 vertices. And why are they oh, come on. Let's delete this. Why are they here? If there are 4 vertices, why are they 6 here? They are 6 because like we see that obviously there are 4. There are 4 vertices, yes, but what we don't see is the triangles. Like actually, what OpenGL draws is triangles. Like this square is actually 2 triangles. And what we're telling OpenGL is draw a triangle. Draw this triangle with these vertices, and then draw the other triangle with these vertices. And look at how these two repeated. And what element buffer object gives us is that we can just say these are the vertices. Like this is vertex 0, 1, 2, 3. And just draw the first triangle with 1, 0, 2, and 1, and the other triangle with 0, 2, and 3. This is how we can send just only 4 vertices instead of having to send 6. And with the additional information each vertex has, like color, textures, etc. That's the difference. And this is and this indices array is just that. This is our indices array. This is our indices array. That's what we will need to create. The issue is that we will have another rectangle. In our rendering batch, we have another rectangle. We have another rectangle, and his indices are like 4, 5, 6, 7. And the other indices should be like 4, 0, 1, 2. Okay. I've messed up the order. It should be like 4, 5, 6, 7. So here it should be like 4, 6, 5, 4, 6, 7. This is again in our indices array, the next ones. And we will generate them by, you can notice a pattern here. The only difference between these ones and these ones is that we have an offset +4. Like it's the same ones, just +4. And the other ones will be the same as these, just +4. And this gives us a hint of how the EBO array should be like. But the coordinates, the data for each vertex, we don't know that. That's why we've set it as dynamic, because we will change these. Each vertex will change, but the EBO indices, they will stay the same. And we have to generate them. We set them once and we leave them like that. We set them once. What should be the size? Yeah, it should be the same as here. No, it should be even, no, it should be like 1000 times, like each square should have 6 indices. And we go through, we'll create a for loop. Int I equals 0, I less than 1000, I plus plus. Now we're going through each square, and we will yeah, in how much should it be? So int index in index should be I times 6. Yeah. And we set indices index plus 0 equals 0, and then we paste this. Okay, we have 6 of them, and here we set this as like this, and this is like 0 to 1, 0 to 1, and this is 0 to 3, 0 to 3, like that. And we need an offset, because what this will do right now is like for each one of the squares, it will generate the same EBO. Like from 0, it will use from it will use the same 4 vertices. And it will ignore all the other. We don't want that. We have to add the offset, and the offset is 4, but it continues to increase. So int offset equals 4 times I. So here it should be like plus offset. Yeah, like that. We've created our EBO. And now we need to bind it, I think. Bind. Okay, we need to switch to setting now. We need to bind it. And we need to set its values. Yeah. And that's it. We've set our EBO, and look at how here it's static draw, because we will not change our EBO. We will not be changing our EBO. Now, what else? We have our vertices. We have our vertices. What else? Yeah, we've set our constructor. And we want to be able to add an object, to add a block. And when we add a block, we'll just fill in the vertices. But do we need to be able to remove a block? Well, no, because when we want to make a change, we'll just create new render batch. Or we can just set it as don't render if we don't want to render a block. Or if we want to change a block, we just change the vertex data. For now, we don't need actually to change it. But it's interesting how we'll handle change. Let's create a void add block. Let's have an add block. Can we actually set for our blocks to set capacity? CPP vector set limit. Can we set limit? Oh, they are just setting wrapper. Okay. Okay, when we add a block, when we want to add a block, we can return a bool if it has been added or not. Bool return true by default, and if batch size is, if blocks size is if the size is equal or more to batch size, return false. Modifiable value like this. Yeah. And here if we have reached this point, This means we can add a block. We can add a block, and we'll add it by blocks push back block. Actually, actually, yeah. Yeah, yeah. So we push. What I was thinking was, do we? I was thinking if we need to track our blocks. Do we need to track them? But actually, yes. Actually, yes. Because I was thinking, why not just here work with the vertices array and just in the vertices array put the vertices and don't and only track how many blocks we have in the vertices array. But we'll need the vector of blocks. We'll need it. Next. We want to render them. Yeah, to render them. And for rendering, we will first, before rendering, we need to update the void update vertices. We need to update the vertices. Yeah, we need to fill in the vertices data. With each one of our blocks. So here inside, so here we go through four blocks. Was it like that? Block. Yeah, it worked. Is it called block? Block meaning a large solid piece of hard material. Okay, we'll leave it as block. Would have been better to call it square. Okay, for each one of our blocks, actually, we want actually need not only the block but which block it is. CPP for each in vector. With index. I want to get the elements. Uses iterator. Yeah. Oh, but they also use a reference. Yeah, so that they don't make a copy. And we can just count 0. This is the fastest way to do it. I just want to keep it naive and simple. So it's easy for me and the average viewer to understand. Okay, we need to store in our vertices float array just to store our own vertices. We'll do that by setting index. No, let's just keep it as count. Vertices. No, it should be like so block has a vertices array, right? No, it doesn't have it, but we'll create one. We'll create one here. Like if I do it as 4 times 4 and we remove this one and this one, yeah, now it has vertices, and here now each block has vertices. How can we cpp concatenate arrays? How can we concatenate them? Like, is there a function for that? Or I have to do it my own? Okay, the result is new array. No. Okay, I'll just do it on my own. So how to add each one of the vertices? That's what I'm wondering. Like the easiest way, I know one way to do it, but maybe it's not the best. We can go through, like, we have to go through each vertex of the block and just add it. So we can have for int I equals 0, I less than block vertices length, I think. Why is it not vertices? Why is it confused? Expression must have class type but has float. Oh, CPP get size of array. Get size of array. Size of. Cool. Size of. And then I plus plus. And then we have to fill in our own vertices. So vertices and then count. Like we can store it in a variable the size of block vertices. Block verts size. Good luck with this. Thank you. I'll need the luck because this is a very ambitious project, man. And I just know the basics. I just know the basics. I'm not even good with C++. But I really want to, like, this is the way I learn, by just learning some basics and playing around with them, trying to achieve an ambitious goal. Because I progressed a lot. with my knowledge. I even went through I even went through this tutorial. Like, this is a lot of videos, like 60 videos on making 2D game. I'm on video, I think 14, texture batching. And the issue is that his videos are with Java and OpenGL, but it's not that big of an issue. So here we will copy the size of each block. We'll copy the size of each block, and here, instead of calling it each time, we just say block vert size. And here we set count times. What should it be actually? Like the current index that we're targeting. Like here it should be for sure plus I. Plus I. And here index will be like the offset. It's better name, offset. The offset is I think count times block vert size, right? And then and then here it's offset plus I equals to block vertices I, like that. And this way we're storing the vertices inside one big array. We're storing them in one big array. Now, when we render, we update the vertices. And now that we have the vertices, we need to actually use them. So I think we need to bind again the VEO. Let's bind the VEO. Let's bind we bind the VEO. Like let's copy all of this and we'll see what we will use when we rendering here. Now we bind the VEO, we bind the VBO, and can we just use this GL buffer data instead of what he used, like something like GL sub or buffer sub data? We can use this GL array buffer offset size data, offset 0, size of vertices. Yeah, this should be what else do we need? Oh, yeah, I need it to be like that. All right. Yeah, we change the vertices to be our new vertices. We're doing it every render. Yeah, every render will be updating our vertex buffer object and having one draw call instead of before where we have 1000 draw calls without updating the vertices. That's the difference. Yeah. What else? We can try to... Man, we're close to testing it out and I'm a bit scared. Most likely there'll be errors. Most likely, but that's the fun part. Where is, yeah, draw EBO. And now we draw it. And we have to unbind it. We have to unbind the VAO. And here, draw elements. Draw elements, triangles, where number of vertices starting from 0, number of vertices, size of vertices, like that. Hope this works. But should it be like times float, etc.? No. No. Okay. And now we can remove the draw function of our blocks because we will not be drawing them. And we also remove this init function. Like this initialization is just, yeah, it will be helpful to have it as reference, but we will not be using it. Yeah, we set the size, color. Oh, we are not setting the color. Yeah, we'll ignore the color for now. But we have to update our fragment shader. And here inside color, we'll ignore the texture. And for color, we will just have red color. We will just have red color. And that's about it. And here, projection, we leave it. Transformation. Yeah, we will not use transformation matrix. Just a projection matrix. And here, we will, here where we create our blocks, here we create them. We will create render batch. We create a render batch. And we will store it here. And here we say batch at render. Oh, it should be public. Yeah. I forgot public. I forgot to set them as public. Batch at. Come on. Yeah, it's a render. Why is it not everything public? Yeah, it should be public. Render batch. Constructor. Add block. Yeah, I want add block. I want to have add block. Let's rename it to see if batch 1. Let's rename it at block I. It should be like that. Batch 1. Expression must have class type, but it has type render batch. Yeah. And isn't render batch a class type? What's the issue? What? Quick fix? No. What's the issue, man? But it has type. Expression must have class type. Expression must have class type. What am I doing wrong? It's a pointer, so instead try. Works fine. Yeah, but... Oh, you know... Oh, I see. I see. Like this. Yeah. Oh my god. Here, blocks. Okay, fine. And now we should be able, instead of drawing each block, we just say render batch. Batch. Yeah, just let's call it just batch, not batch one. Batch. No, it can be render batch. And now here, render batch render. Oh my god, it's time for testing, man. I'm so not ready for this. Urachi, Mr. Urachi, I need your luck. I need your luck for this. Let's test it out, man. Let's test it out and just see the error. I know there'll be a mistake here. What's the problem? These were for the configuration. Yeah, this from CMake. This is not our issue. Output terminal. Yeah, but inside terminal, can I clear it? Okay, cleared it. Let's try again. It starts and just renders one frame and it stops. Why? There's not even any error. It just crashes. Let's try here. There's not even an error, man. Like, this is worse than I expected, because I expected an error that should give me explanation what I'm doing wrong. But here we don't even have an error. You know what? We can use... Okay, chat, this is the perfect time to show you an application for debugging OpenGL programs. Render doc. It's called render doc. Does it have dark theme? Tools, settings, dark. Dark, man. Team might require for... Would you like to switch to new team? Yes. Okay. I saved your eyes. It's dark theme. Now, launch application. My game, and I want capture. I want to capture 10 frames, but I know only one frame will render. Launch. And here, look at it. It captured the first frame. Capture start. We clear the color. Are we clearing it with black screen? No, we are clearing it with the color, which is weird. And swap buffers. And that's all it does. Texture viewer, pipeline. I'm not seeing you. No current draw action. Launch application. Errors. No errors. And it just closed. Geo clear. No problems detected. Weird. Even my... Oh, you know what? Yeah, we'll leave this behind. I think the issue, you know what we can try? We can comment this out. We can comment this out. We can try again. I think it will crash again. No, it actually worked. So in our render function is the issue. It's our render function that's the issue. You know what? We can we debug here? If I add here, cmake run, not you, man. Cmake. Why is there a run? I want to run with debugging enabled. Cmake run with debugging VS Code. Control Shift F5. Okay, Control Shift F5. Nothing happened. Okay, chat. I need a quick break. Chat. I'm back. Stand up. I'm back. Change. Yeah. Let me fix the mic. And let's. We need to. I want to see if I'm able to debug the program, but we can. We have audio and yeah, we can just use prints. Yeah, we can just use printing to the console and see how far we can go like this. I have to check if you guys have audio. Here we can just this will not work, so here we can say we can copy this and print out like debug, and here we can print out size of let's actually use here we can call render batch blocks size. Yeah, let's print out the size 1000. Size is 1000. Let's close it. Okay, blocks are added. Let's see. Yeah, but so it crashes when we hit render. It crashes when we hit render. When we render, we update the vertices. You know what? Let's actually let's move this debug line. Let's move the debug line here after debug vertices, and here we will print out a size of vertices, and let's test it out. No, we are not reaching even this part. Are we inside the start of the function? What happened? Update vertices, yeah. Are we inside the start of the function? Yeah. Yeah. Okay. Okay, we got this. Hopefully we got this. What will we do is let's comment this out. Let's comment it out and let's check here. Actually, let's see here and here. Count. Let's see here. What? We've reached. I feel like an error should be given because here probably we are filling up all the vertices and we don't have space. Probably I have miscalculated something. And we should be getting an error. But it just crashes with no errors. Oh, we can... Let's a Visual Studio. Let's open it here. Let's start it here to see what here we will get in Visual Studio. Look at it, man. In Visual Studio, we get proper error reporting. Exception thrown in my game. Access violation, writing, location. And we get data, what's the offset. Oh man, this is much better than what we had. Much better. Now. Oh. Block word size 64. This is because it's... Yeah. I shouldn't be using size of here. It's a mistake. I should be using... like I want how many elements there are. I just don't want so many hard-coded values because afterwards when we make changes, we have to change a lot of places. Let's see if there's something. CPP get number of elements of array. They're saying size of, but yeah, isn't... Oh, we have to... Oh, it's size of divided by size of block vertices, the first element. Yeah. Now this should probably work. And it's my game exe. Okay. We don't need stack around variable render batch was corrupted. Whoa. We have to probably properly stop it. Like when we stop the game, we probably need to handle closing our render batch. But let's see. It's running, but I want us to stop this debug message. Yeah, inside the render batch, what it's complaining here. Inside update, and here our debug message we deleted. Let us start again. And we're getting only the FPS now. Cool. Now what we can do is we can go back to render doc. We can go back. Where's render doc? Man, so many applications open. Here it is. Let's launch our application. And we will not capture anything right now. And here's the game. And look at what we can do. It's the same game, but here we also get FPS and which frame we're currently on. And here we can capture with F12. We've captured. And now we can open this screenshot. We can open it. Let me... yeah, I'm banning you. Somebody on Twitch is trying to be rude. Okay, you're banned. Yeah, so let's go back here. We can open the screenshot. Yeah, we've opened it. And here we have draw elements. What? 64,000. Do we have anything on the screen? And here we have drawing our color. Sure. But do we have meshes? And look at this. This is the input. 64. What? Is it correct? Error obtaining vertex data via transform feedback. Okay, there's an error here. No. Yeah, error obtaining vertex data. Yeah, look at how all the values are zeros. This is what we want to see. All the values are zeros. Look at all of this debug information. All the values are zeros. Okay, let's check a few things. Like we can close this. We can close this. Every time when we close the application, we get an error. We have to solve that as well. But before that, I want us to here. I want us to check where is it? Here. I want us to check. What do we need to check? Now here, draw elements. I'm saying size of vertices. And change subdata. We're changing it. So actually we can check. Oh yeah, we can check here. Can start. We can check here now. Let's look at vertices. Look at how vertices is all zeros and ones. Okay, there are values here. Were they 0 and 1s? Oh, I see. They are 0 and 1s. Okay. Let's stop it. And let's... they are 0 and 1s. We can change them here. I think this was color. Or texture. Yeah, this is texture values. Here we can have it set as size of 10 units. So the blocks should be top left of the screen. blocks should be top left of the screen, but let's look at our vertices. Do we have them? Yeah, 10, ones, etc. This looks fine. Let's stop the application and let's actually debug once more. Yeah, in the VBO it's all zeros, but let's launch it again. Let's launch it again. Let's capture. Let's open it and let's see mesh data. No, nothing. Nothing. Error obtaining vertex data via transform feedback. Error. Can I copy this? Error obtaining vertex data. Така. What should this mean? Transform feedback. Да. Can we check each of the shaders? Pipeline, vertex input. Vertex shader, fragment shader, no resource. This is for the uniform, I think. How do we do this? How do we do this? Man, we're still at trying to spawn more like 50,000 squares, not 10,000. Our goal is 50,000 squares. We're still trying to do that. Where's the issue? One thing I saw him do that I'm not doing is this, enabling the attribute array. We can try doing that. We can enable and GL disable. Vertex attribute. Like, what was it? GL disable. Yeah. We can try this. We can try this. Let's once again debug here. And we can, we can just capture like frame 100 and capture just one frame. Launch. It's just waiting for frame 100. But we passed it. Let's just capture now. Yeah, because I didn't enable it. Okay. Let's see, mesh viewer, pipeline. Here. Still an issue. Error obtaining vertex data via transform feedback. Really weird, man. That's really weird. It's even. Oh, it's even not. Yeah, I think. Has it crashed? I see here a Terraria game. But it's not. It's not responding. Can I target it? my game. Let's end this. To sit down. Yeah. Oh man. This is such a hassle, man. This is such a hassle. Why do I have this window? Terraria player. Task manager. What do I need to close? CPU. There's an application running that I don't know why. Let's start here. Yeah, it runs. Okay, can we solve this? Stuck around the variable render batch was corrupted. We can, let's see what we can clear. Here, let's create a void clear. Oh, and when we update, we can say, when we update the vertices, we can say vertices. Can we do like this? I want us to modifiable. Can I do like this? Like I want to clear all the values. Do we need to? CPP array set all zeros. I don't think we need to. Let's here call, after it's done, render batch clear, and let's see if this stops the problem. And now when we close, render batch was corrupted. Why? Render batch, it has vertices blocks, block size 0, we cleared it. Batch size, vertices, VO and VBO. Okay, can we call? Yeah, let's actually see why error like this shows up. Let's see why an error like that shows up in the first place. Are from 0 to max is past the end of the array. So here he sets up until max. Okay. Valid indices are from 0 to max minus 1 inclusive. Max is past the end of the array. So he's setting past the array. So that's probably what I'm doing wrong. Yeah. Okay. We'll delete this. Somewhere I'm putting values where I shouldn't be. Let's see now. For our indices, we set here. Indices should be fine. Like let's do a quick test. We can do here we will not render, just have the constructor called. Let's see if here we have an error. Okay, the issue is not with indices, right? The issue is not with indices. That's good to know. So the next candidate is update vertices. Update vertices, and let me pull up the chats. Okay, update vertices. Update vertices, we go through each of the blocks. Fine, we have the count. Block vert size. Yeah, we update the vertices. Actually, let's do it like this. And let's delete all of this and let's ignore this. And let's just bind the VO. Here where we draw elements, I haven't used EBO in a long time. Shaders, hello triangle, is it here? I want to see for EBOs. Indices, EBO, draw elements. Okay, we have an issue here. So this is 6. Yeah. It should be. Yeah, it's the amount of vertices. So here it should be actually like 1000 times 6. Yeah, it should be like that. Let's see now. And we close. No issue. Now let's get this back and let's start. Okay. This is another issue. Now when we update them, when we're updating the vertices, I'm making an error, sure. Update vertices, we're having an error here that we're not seeing. So vertices, let's set here in test 1 just so I can debug here. And let's see our count. 1000. Okay, the count reaches 1000. Oh, I see. We are increasing the count too early. Oh my god, that was the issue. Oh my god, that was the issue. That was the issue, man. Let's see here. We increased the count too early and we started from 1 instead of from 0. Oh my. Dude! Look at here. We have squares here. I think we're drawing. Okay, let's let's calm down and let's see. Let's check our render doc. Oh, we've closed it. Render doc. And let's launch our application, my game, and let's capture frame 100. Let's launch it. Here we have frame 100, and let's see what we have. Okay, we're drawing 6,000 vertices. We're drawing mesh viewer. It's still zeros. Then how is it drawing? Here. I'm confused. We are drawing here swap buffers. Like I can see clearly on the screen here we have a little square. We have a little square. But here it tells me that for mesh viewer, when we draw, it's only zeros. But we have something on the screen. Why is it zeros? We clearly have something. Pipeline. Okay, let's close it. Let's look at here. No. Where is our code? Where is our code? Here. And let's oh, you know what? We can use the matrix here. Oh my, we can use it here. Can we? Yeah, we can set here where we set position. Like we can let me think. We can set here GLM matrix, transform matrix, and we can say vertices equals transform matrix times vertices. Can I do this? Okay. Issue. We have an issue. GLM. How can we... Like, do I have to change it into a vector? Like vec. And it's actually... Or is our own thing... Oh, we... no. Multiplication, like this is wrong. Multiplying by matrix, it's actually like it should be these values times our matrix. Then these values times our matrix. Oh. Then these values times our matrix. And then these values. So a vector too. So it will be a hassle. We can... Yeah, we should just hard code it. Sadly. Let's set like this vertices array. We can set it here and here like this, and here we can delete it. Can I do it like that? And here modifiable value. Do I have to... cpp update whole array. Cpp init whole array. Yeah, this is for initialization. I want afterwards. Cpp set array. In C++ 11, I can do it. Oh, it's a vector? Why is he using a vector? I think I have to create a new array and then copy. Okay, I'll just float new vertices. And here 4 times 4. And here we can just do what this guy does. Sadly. I wanted something better, but... Okay, we can use this then. Here, new array, new vertices. Array. Here it's vertices, and here it's new vertices. It worked. Okay, and here it should be and here, how can we set the position? How can we set the position? We can just create it here. We can just create it here. Like it can be 1 unit square, and but these are the texture values as well. These are the texture values as well. We can... These are the texture values. How can we set the position? Like if it's plus X. Oh, yeah, we can set it here as this is plus X, right? And this plus Y. Yeah. Yeah, and here we'll be just doing it like this for now. It's not the best way, but... And here it should be size. Size. Yeah. Size. Size, and here size. And now when we create the blocks, when we create them, where did we create them? Main. Here we create the blocks at the position and size. This is just the blocks one on top of each other. Here they are, but we need to make them bigger. 100. Here they are, but we are not rendering them properly. The order is wrong in our case. We can see it very easily if we draw it. Here. Now the vertices are actually... let's copy it here. Let's copy, and let's see now like this. So the first vertex is now where is 0, where is 1? Like here it should be like 0, increase, increase. Top left is 0, and here increase, and here increase. So if we say size and size, increase, it should be here. So here is 0. 0 on X and Y. This is the other one. And here it's 1, 0. So this is the next one. And then this is the last one. So they should be, the indices should be like currently how they are now is like this. Like this. We want them to be like what? So now it's 0, 2, 1 and 0, 2, 3. So it's drawing, and we can even see it. It's drawing this triangle and this triangle. That's why we get this. Oh, yeah, that's why we're getting this weird shape. It should actually be 0, 3. It should be 3, 0, 2 and 3, 0, 1. That should be it. So if we go back here, where our indices are, indices here, it should be 3, 0, 2, then 3, 0, 1. Yeah. And now we should have the blocks. Yeah. And now in theory, we should be having on screen 1000 blocks, actually. Right? We should be having... It's saying 50,000, but it's actually 1,000. Because our render batch is limited to 1000. Yeah, and we have really high FPS because currently it's only one draw call. Let's even set it here to be plus 100. And 1, let's say. Just so we can see there are more than one block. Okay, this is weird. How many blocks are drawing on the screen? I think this is X. Yeah, this is the X. Oh, it should be I times this. It should be working. Yeah. And here, this is the first block, the second block, the third block, the fourth block, the fifth block. And all of this is happening with one draw call. With one draw call. This is really important. This is happening with one draw call. And here we can even decrease the size to 10. And here 10. We can draw again. And here we have these are more like they're still going to the right outside of the screen. But we're drawing them. We can just have them one on top of each other, increase them back to size 100. And this time, now let's, how can we get 50,000? 50,000 blocks. How can we get them? By creating, let's even have a git. Render batch. Let's make a commit. Okay, and now we will create a renderer. This is render batch. We'll create another class. Class renderer. In this class, we'll have a vector, I think. Std vector, not you. Oh, come on. A vector of render batch. Batches. And here, when we and here we will have how will we do it? How will we do it? How? Because when we want 50,000 blocks, we will need 50 render batches. So we will be doing 50 draw calls. That's what we will be doing. And here, how will we do this? Here, how will we do this? So we will need for sure, okay, let's public. Here we will need for sure void we will need add block. Yeah, add block. Now we go we also need a renderer. We need a default constructor where by default we'll create batches pushback new render batch, right? Why is it giving error? Batches. How do I do it here for blocks? Yeah, just push back. You know what? Here, like this, or like this. Test. Render batch test. And here, test. Yeah, this works. Like this works, but if I do render batch, this doesn't work. Like this. Okay, this works. Okay. We're in just giving one render batch here. Function uses bytes of stack. Consider moving some data to heap. What does this error mean? Okay, can we, if I do it like this, there's no error. First batch, but let's do it like this. Like, no worries. No worries. And now, when we add a block, okay, here what? Okay, it's the same problem. It's the same problem. It's the same problem. Let's see. Function uses consider moving some data to heap. Consider moving some data to heap. It's basically allocating new object. Is it just like new? Oh man. What's his issue? Random int. And here he says randomer. What's randomer? Yeah, randomer. He's just doing it here. And here he's saying you can replace your variables with new randomer. Yeah, I need to use the new. And to use the new, I need to change the type. Like this. Yeah. Will this solve it? Okay, this solved it. Now we are just using the heap. And every time we have a new, we have to delete as well. Because this will lead to memory leaks if we don't delete it. Can we make a destructor? Was it like this? And then cpp new delete. New. Now we're using the heap, but we want to clean it. Every time we have new somewhere, we have to have delete. Yeah, delete. So for render batch, render batch in batches, we say delete render batch. And here, do we have to do it like this? Yeah. And we delete them every time this class is destructed. So when we add a block, do we have to do it here as well? Yeah. Here, blocks. And here, does it have to be a reference? Or like this? And here, oh my god. And here I think like this. Like this. We have to dereference. Here we have to dereference. And we make a destructor render batch, right? And here we'll just repeat the same thing. here I have to stand up. Stand up. Here we will clear all of our blocks. Now we will be using the heap. Do we actually need to? Block, blocks, block. And here, new, like this. Okay. And now, render batch. Now we're dealing we just, I think this is the what do we need now? Now we need here, when we add a block, let's get the last render batch, our last one. Render batch, batches, cpp vector get last element. Back. Is it like that? Oh, last render batch. Yeah. And why is he doing .c? Oh, he wants to access an element. Okay. And now we say we try to add it there. If last render add block here it has to be like this. If this doesn't succeed, what do? We create a new one because there's no more space. So push back new render batch, and then we add it there. Back add block like this. That's what we do. And now inside our render, we go through each one of our, and we say render batch render like this. And now here we create the renderer, our renderer. And here I think the name is quite bad, but we'll stick with it. It renders, and now can we count how many blocks we have on screen? Now we can actually try here 50,000. 50,000. We should be having 50,000 blocks on screen. Now the FPS is perfect, 160. And we're seeing one block because we're rendering one on top of each other. And I'm not sure how can I confirm how many blocks we have. How can we confirm the amount of blocks we are rendering? Let's try once again our render doc function. Let's launch the application. Here it captured the frame. And here, okay, we are drawing quite a lot of elements. It should be 50 of these. It should be 50 of these. Mesh viewer. Like, it still says there are zeros, but I don't believe that. Oh, here is what's being calculated, I think. Launch errors, mesh viewer pipeline. Yeah, I'm just still new to this application, so at least it's drawing all the elements, most likely. Let's close this. Let's go here and we will, to test it, we'll try to display all of them in one time. But before that, there'll be a quick break. Okay, I'm back. Okay, there's audio. Let me bring up chat and let's see now. How can we create? How can we? I want us to fill up the screen. I want to fill up the screen. How many can we fill up? Like there, the size is I think 1200 by 900. Yeah, 1200 by 900. And now we want 50,000 blocks on the screen. You know what? We can do that. Let's have it like this. So it's 1200, so 12 for loops. Let's create 12 for loops. And here it will be we don't even need this array. Like this, and here like this, and here like this. And here we delete this. Now, when we create each block, this is the position. So the first block will be at 0, and here, yeah, and here should be 0 as well, 100. Now this is for the color. We can leave the color. We're not using it. Okay, it's on there. We can we have to make it smaller. Size like 50. We have to make it smaller. 50, but filling this up will be, or 16. Can we make it 16? Like, because Terraria 16 pixels. Each block is 16 by 16. Okay, we have 16 there. Now, what we will do is create let's create a flat big world, and let's make it let's make it here plus I times 17, because I want 1 pixel space between each of them. Now if I run it, where are they? What? I just changed this, right? Yeah. Where are they? Plus I times 17. This should work. Nowhere to be seen. Why did they disappear? At least the first one should show up. Let's change it to 16. Why not? Still nothing. Plus I 0. So it should, the first one should be exactly the same. Oh, let's debug. Let's debug. And here, let's continue. And let's see the renderer, batches, blocks. And here we have x0, y0, and size 16. the vertices, perfect. View, texture. Oh, I have notifications on, I should stop them. Why? Yeah. Somebody in Discord needs help with my tutorial, but I can't right now look at it. Why is it like this? Let's make the blocks bigger. That shouldn't be the issue, but let's do it. Here, let's make them bigger. Still the same. Oh, you know what? We can test. Let's delete this and let's tell it to be like 100. Okay, we can change the position. But why cannot we? Let's hide this. Why is it not? Okay. Let's hide this and let's copy this and do it manually to see what's the issue. Like 0, 1, 2. Now this should render 3 blocks. Yeah, it's rendering 3 blocks. Oh, we can just limit this to 3. And now it should work as well. Yeah, it works. Oh, maybe like we're doing 50,000 to the right. Maybe there's a limit to how far off right we can go. Let's see 1,000. It should work 1,000. Let's see where the limit is. 1,000 works. Perfect. Now where's the limit? 1,001. They should create a new batch. Okay. Here's the problem. When we use another batch, that's where we have an issue. That's when we have an issue. So we add a block. Where do we? Here we add a block. So we get the last render batch, and this usually works. And here it's this is false and it doesn't go inside here. But our last run, when we last run this, we couldn't add a block in our last render batch. That's why we are making a new one. We're making a new one, and now in the new one we add the block. Actually, we can try recursive call. It's not working. Let me try here. Debug. Oh, but it will do it 1,000 times. Let's add here, actually. Here. And let's debug. And let's see. We now have 2 render batches. And this has 1,000 blocks and the other has 0 blocks. And we let's step into. Okay, I need to change to sitting. Sit down. Why is the camera not registering? The camera should be working. Why is the camera not showing? Not showing anything. But standing up, we have picture. Sitting down, we have nothing. Why? Why is the camera deactivate, activate? Why is it not? Chat, I need to, or maybe the GPU cannot handle performance. Memory. Okay, OBS is using up quite a bit of resources. Why is it like this? I can just chat. I'll have to. Here. Sit down. Yeah. Oh, it works. Oh, come on. So many errors and problems. But we finally got it working. Now, maybe it just was trying to handle too much. Now, properly. Okay. Now we were debugging, I think. Step over. Okay, which one did we get? Yeah, blocks. We are getting the one with size 0 blocks. Okay, and we last render batch. Oh, I think we. Okay, blocks 1. Okay, let's look at batches. Yeah, blocks 1. It's added. One, and it's everything proper. So where's the issue? When we render, we go through all of them right here. We continue. Now, this is the one with 1000. Continue. And this is the one with 1 block size. Let's go. Did we? Oh, we stepped over. Oh, come on. Let's continue. Yeah, block size 1. Step into. We update the vertices. And now the vertices, yeah, they have value. Yeah, they have values, some big values. Yeah, they have values. And we bind the VBO. Is the problem that we are drawing once again too many elements? What's the issue? Oh, you know what we can try to debug this? We can try setting the block count, like we can set the limit for each render batch to be like 1. Each render batch can render only 1. And when we say render 3 elements, we can see where the problem is. Of where continue. What's the issue? Now, like right now, if we render, we have 1 block. And it's the, like, let's render more blocks. Now it's 1 render batch per block. Just so we can see why are not all of them working. Let's render 10 blocks. And they should be starting from top left. Okay, only the last one renders. This is interesting. Only the last one renders. Why don't the first ones render? Renderer, render, render, and we here render, we go through each of them, but only the last one renders. This one has VO1, but the VBO, I think it's the same one, 845. 845. Oh my god, don't tell me the VBO is the same one every time. $845. Oh my god, I think the VBO is the same one. Yeah, probably the VBO is the same one. Why is that? Let's see now. Yeah, when we create one, we... Oh my god. What a dumb mistake, man. I was having a local VBO here. Now it works. Oh, come on. Now it works. Okay. Now let's go back and set the limit of each batch to be 1000. And let's try to render 1001 reconnected successfully. Performance. What's the issue? Chat, I think the game is messing up with the stream. Okay, GPU looks fine. Processes. OBS taking my game. The game is running quite well. OBS is running quite well. Twitch stream has ended for some reason. I'll start again. Okay. Now, we're spawning 50,000 blocks. We're spawning 50,000 blocks, but the issue is that they're only on one row. They're only on one row. Let's add how much rows? Okay, 10 rows. If it's 10 rows, there will be 50,000 per row. Let's make 100 rows. So let's add 4 int row, and row will have 1000 rows, and let's for each row we'll have 50 blocks per row. And here it should be like column. Column, and here column. And now let's start. What? Oh. We want here on the y-axis plus row times 17 f. And now let's start. Oh, we are rendering quite a lot of blocks. Let's see if we still have, we are still streaming. Twitch is unstable. Why? Average stream bitrate too high. Okay, that's weird. And YouTube is excellent connection. Okay. And you can see how our frame rate is 160. And before, each one of these would have been one separate draw call. This is really nice, but let's actually have here, let's have 500 and here 10 rows. If it's 100, if it's 100, it would be, yes, 1700 height. It would be 1700 height. So the blocks will be a bit after the screen. Actually, okay. Most likely we're drawing currently 50,000 squares with 160 FPS. This part is done. Spawn 10,000. We're spawning 50,000. This part is done for 3 hours. And we're rendering, we're using probably, so 50,000, 50. We're using just 50 draw calls. We're using just 50 draw calls. Whereas in our version before, this would have been 50,000 draw calls. And look at how smoothly we're running, man. Yeah, and now it's time for the camera. Now it's time for the camera. Now it's time for the camera, right? Yeah. For the camera, because what I want is, when I say camera, I want us to have a camera that we can move around and we can zoom out and zoom in. Just so I want to see all of the 50,000 blocks. I want to see all of them. Yeah. So that's what we'll be adding right now. Man, these are so many blocks. Look at how when I move the window, OpenGL stops. And then it continues. That will be interesting to see why. Okay, let's commit it as I can render as many blocks as we want in view draw calls. Okay, now let's create the camera. Let's create the camera, and for the camera, before currently we have projection matrix, and in this guide that I followed for making 2D game, there I saw how a camera is made for a 2D game. In addition to what I found is that in addition to projection matrix, I think a view matrix is used as well. We need one more matrix. We need one more matrix and game camera. Yes. And look at it. This is, I think, perspective, and this is orthogonal camera, and perspective is used for 3D. Sorry, my voice is giving up on me. Have to drink some water. And we'll add the camera. So look at how at perspective, like orthogonal is for 2D. It's for 2D so that it's not like when it's with a perspective, it will be like as if we are, let's open the drawing app. Like I'm bad at drawing, but currently, like our game is like, you will think that this is 2D, but this is actually 3D. This is 3D because when we're creating the vertices, they have an X, Y, and the Z we've set, where is this? Each vertex that we're setting to create a rectangle, we're just setting the X and Y, and the Z is always 0. X, Y, and Z is always 0. But we can use the Z. Like, when we are talking about the camera, we are still in 3D. So we're using the orthogonal one, because if we use perspective, like currently we're looking at a plane, that is on the z-axis 0. If we looked with a perspective, it would be like as if we are looking it in the 3D. But with orthogonal, we're looking at this flat plane. Like orthogonal is perfect for 2D. And yeah, we need another matrix just so we can have the camera with this look at function. I hope that we have a look at function in C++ because he's using Java. Projection. Yeah, he has a projection matrix and a view matrix. The view matrix is what I'm interested in. So he creates the orthogonal one, which we already have. We already have the orthogonal one. We already have the orthogonal. We need the view matrix. Okay, here get view matrix. He has a camera front, camera up. He starts with identity. He uses look at. And he returns it. Okay, this is what I needed. This is what I needed. Now, now we will. Here it is. Oh, come on. Here it is. This is the matrix. Yeah, okay. So what we need, okay, we will start with the identity matrix and we'll multiply with this look at. I hope GLM has a look at here. And we will go to the projection matrix. And here, let's, we will, do we have here, should be matrix 4, view, matrix, GLM, do we have look at? Okay, we have look at, perfect. What does it want? It wants an eye, center, and up. What does he use? He uses, okay, front, camera front and up. Let's see what arguments he gets when he starts typing. Okay, he has the same eye, center, and up, right? We have eye, center, and up. Perfect. All right. Oh, I think we can do this, man. I think we can do this. Now, we need, okay, the center. The center is a vector with x, y, and z. Okay, so x, y, and z. Here, let's set them as floats. We will set the position as 0 on x and 0 on y, and the z just 20. So we have space between the plane and the camera. So next is the center. Okay, let's camera front and camera up. Let's create those. GLM, vec, I think 3. Camera front. Camera front equals and z minus 1f, and then camera up. Camera up is 0, 1, 0. 0, we'll make sense of these values once we get it working. And here for the center, it's camera front plus. Okay, let's have let's have a position. Let's have a GLM vector camera position like this. And here can we do camera position? Okay, I think we can. And here camera position. Oh my god, why did I write two eyes? Eye. And here I'm just looking at the stream if it's still on. Camera position, and here we have 0.0, and then okay, here it gives an error. Expected expression. Okay, how can we add we have vector 3 plus okay, let's test. Can we do here GLM vec3 test to be camera front plus camera up? Can we do this? Yes. Okay, so here we'll do GLM vec3. Can we do like this? Okay, we solved the error. And now camera up. Camera up. We need word wrap. Word wrap. Perfect. Now we have a view matrix. We have a view matrix. Now let's use it. Let's use it here. Let's use a view. And here view matrix, but we need to create it in the fragment shader here. Man, this is one ugly fragment shader. We need uniform here in the vertex. So here should be view. I'm not sure what the order should be. Projection, view, and then this. Should be like that. Now where are we looking? Let's change the position. Camera position, let's change. We can let's move it like 450 down. 450 down. And let's see what we will get. Nothing. Oh my god. Are we making mistake? Are we making mistake? View. We are setting the view matrix. What are we doing wrong? Are we doing something wrong? Let's think about it. We can use the debugging. I'm trying to move the camera. First, let's think if this is correct. Okay, camera up, this is the Y and this is 1. I think this is 1. Should it be -1? Let's move back the camera 0, 0. It should have position 0, 0. I'm not sure. Camera front. Man, if I had chat to help, that would be a lifesaver. Let's bring it. Can I uncomment? What will happen without one? Without the view matrix? Yeah, but it initializes some default values. You know what? Let's debug it. Let's see what we are getting here. Let's launch it through here. Okay, we have captured the screen. Pipeline mesh. Here we are drawing. Oh, look at this. We're actually getting here values. Before we didn't have values. Interesting that only these are changing. Yeah, but this is for the meshes. This is for the meshes. We're drawing them. Let's look at the pipeline. And let's see here. Oh no, not this. The vertex shader. We should be getting something here. Create program, attach shader, link, buffers. Man, I have to learn this. I have to learn this application. What I'm trying to see is inside the vertex shader, are we setting the uniform correctly? You know what? We can go back. We can hit this. We can start. And let's check our view matrix. This is our view matrix. X, Y, Z should be fine. So what's the issue? The view matrix is being calculated. We can test if this is correct. Yeah. Let's test a vec3 if this is correct. Yank inside here. Paste. Now here. And let's see if it actually creates a vector 3, a proper one. And let's don't reset it. Let's, oh, come on. Let's here. This is 1 and this 2. And let's try again. Okay, our test. Yeah, 1, 2, and 20. Perfect. We are not seeing them. Okay, let's actually ignore the view matrix. And we will see if the order of multiplication is all right. Here, let's ignore the view matrix. And let's run it. Yeah, we get all the blocks. Let's switch the order. View times projection, and we ignore this. Let's see as this. Still the same. Let's projection view. Okay. Now let's look at our. How did he do it? I want to see his vertex shader. Scene setup. view matrix, projection, camera. Where is he changing the camera front identity? Yeah, we did that. View matrix. Okay, here is the shader. He should be adding uniforms. Okay, projection and view. And he should multiply the position. Alright. Okay, here he's uploading the information of the matrix. We know how to do that. Yeah, he's uploading them, drawing them, but he still... Okay, now he should multiply projection and view. Yeah, projection times view. Exactly what we're doing. Okay, what's this adjust projection function that he's using? He also couldn't see them because they were too small. But we don't have that issue, I think, because we changed the size. Where is his adjust matrix? Adjust projection, because he used it. That's the only thing we're not doing. Adjust projection. What is he doing in adjust projection? Adjust projection. This is it. He's just creating them here. Okay. We can also search online for how other people create view matrix C++ example, GLM example, because he's doing it in Java. Okay, this person is using 0. Okay, his center is 0. His what's this? His up is 1. Oh, but he's doing it 3D, right? But this is 0. Let's try that, actually. What we're struggling currently is just with trying to create the view matrix. And because I'm not good with matrices, my algebra is not good, linear algebra, I'm struggling a bit with this. But let's try. What happened here? Here we will change up until here and say like he did with zeros. We will see with zeros how it performs. Oh, we have now something on the screen. Okay, I need to switch up. We have something on the screen. Let's start it. I have to move up. I have to stand up. And let's check. Yeah. So it's actually doing something. Not what we want, but it's doing something. I'm trying to set up the mic. Sorry about that, but there's no other way around this. Yeah, this should be perfect. Let's switch and open the chats. Yeah, okay, perfect. Now, now look at this, man. We should have, we should be having a lot more. Okay, let's actually let's change it here to be camera front. Let's change it to be 0. And let's start again. Okay. Man, view matrices are so complicated. Camera front. You know what? We can actually go back here. I think they said something here. Coordinate systems. Yeah. So local space, we move through that. World space, view space. This is what we're trying to see. View space. What people usually refer to as the camera of OpenGL. View matrix. Yeah, we need view matrix. Yeah, orthographic projection. Sure. Yeah, we did this. We don't need perspective. Yeah, projection times view, model, local. Model is where we can change the local variables with another matrix where we have for moving them, rotating them, scaling them. But currently we want the view matrix. Model, not model. Right hand system. Projection. View. And he starts with the identity matrix, translating the scene in the reverse direction. You know what? We can actually try a simple one. We can try a simple view matrix. Here, test. Like, we will leave that. Let's make a new one. GLM vec made for view matrix. Let's start with a new one. mat4 1. Will this make the identity matrix? Okay, and let's start. This should bring us like where we were before. Yeah, with all of the different ones, different triangles, like different squares, blocks. My mind is just all over the place currently. And what we will do now is actually just translate it to test it. No, we can scale them. We can use scaling. And how did we do this before? Let's look at the reference. Where was it? Main here. And math. Yeah, I stored everything about math inside here. Scale. And let's scale them. Like, if I had to do a view matrix, this is how I will do it. Like, just a regular scale. View matrix. Oh, come on. View matrix. And here our scale will be like, we're actually zooming out, so we want to make them smaller. Let's try 0.5. 0.5. And here again 0.5. And now let's run it. I think it's doing something, but not what I wanted to do. Yeah, I'm scaling it. Let's try making it bigger. Let's try making it bigger. Okay, we made them bigger actually. Yeah. And we can make them smaller then. This should be like zooming out and in. Like this is my way of doing it. Like this camera front and up, I'm doing something wrong there, but just scaling and translating like this as it looks like it also works, so why not? Let's change this to 0.1. Yeah, but as we are scaling it, look at how the scale actually happens. Yeah, because the origin is top left. We have to also translate before we have to do a slight movement. We have to do slight movement. View matrix. We have to translate it slightly. And here, the Z, translating Z, I think it should stay as 1 when we make no changes. Let's try as 0 and we'll see what happens. But for X and Y, we can do, like, I think it's the whole screen size. Yeah, it's the whole screen size. So our width is 1200, so 600. So we are trying to move the origin center. And here 900 divided by 2, so 450. And now should work. Not even close. And like this, first translate it, then scale it, then bring it back. So bring it back like this. No. And let's try this as 1, 1. Still no. Okay, we have to stick with regular view matrix. Like, I think we can do it like this. But it's too overly complicated, because here, just to scale, just to zoom out and in and to move left and right, we have to do a lot of translating, scaling, etc. Whereas here, we just have our camera position. It's much more simplified. So we have to make the view matrix work. Like, no way around this. Like, we have to figure it out and understand what's happening. So here they're talking about some camera front, camera up. Let's see if we have something like some information on this. Rotate Z buffer. Here this person, like this guy, is the best one on OpenGL. For view matrix, he's using just the identity matrix and just translating. He's moving backwards on the Z-axis by 3 units. So I think we have to move to camera. This is it. Okay, camera position, perfect. Camera direction. Yeah, he uses target and normalizes because this camera is for 3D. In our case is 2D. And okay, up, he's using the same up as no, camera up. Yeah, his up is different because it's based on his camera direction, but our camera direction stays the same. Look at matrices that you define a coordinate space using etc. Look at, okay, 3 vectors. And he's using, yeah, this is the same as our, this is zeros. Let's try this one. Let's try this one. So let's set the same values as he has. So position 0. The second one, where is it? The second one, where is it? I want us to at least set up the camera. At least set up the camera and camera movement and without textures. That's where we will stop. So view matrix, camera position, 0, 0. Here for us it's 20, for them is 3. Let's set it as 3. Camera front, for him it's 0, 0. For us, again, it's also 0, 0. Because it's using camera front, okay. And camera up is 0, 1, 0. Okay. Let's see like this. Why? So if camera position is 0, 0, I think probably, here is what I'm thinking. I'm thinking that the camera is working, it's just that our position is wrong. We can try moving backwards here. Let's see if this changes anything. This should be the Z. No, okay, you know what? Let's try moving back in the negative on the Z-axis. Maybe this is what's causing the issue, but let's make it smaller, like 30. Let's also try here 0. This is the position, our Z value. And for the Z value, I'm not sure where. Oh, it worked. A Z of 1 worked. A Z of 1, dude. A Z of 1 worked. Now, what will happen if it's 2? If it's 2, okay, it works only if it's 1. Because I think, yeah, this is our zoom in, zoom out. Okay, then why? I think, look at this. Here, no. Here, where he set the cameras. Look at this. What I think the problem is, I think the problem is that here he mentioned there is a clipping point. Here. Let me screenshot it. And let's move. Let's move to our drawing board here. And let's paste it and look at it. Now we've set it that what we are missing, I think, the issue is this near plane. This near plane, because here is our camera. Here, this is all of our squares. And we've set it like, let's say, like this is z-axis 0. And let's say this is 1. And let's say, how can I draw it better? Here is 1 on the z. Let's say this is 2. And what I think the problem is that our clipping point, the near plane, I think it's like here. It's of size 1. So when our position is here, we can see it because it's in our clipping point. Right? You know what? Let's actually, to see if I'm correct, let's do here. If it's 0, it will not work. But let's see if it's -1. -1. If it's -1, still the same. So for now, only when it's 1, it works. Okay, let's make it. Our goal is to make it work with bigger numbers, like 30. And I think this will be like our zoom out. And you know what? Let's try. I have another idea. Let's try 1.5. Let's try 1.5. Still the same. Okay. What about 1.01? Still the same. Let's make it work for like a value of 2. Let's make it work a value of 2. Let's see why it's not. Okay, we have camera position. Let's see if camera position works. Let's change it to like our X and Y. Let's move to the left by 100. To the left by 100. Okay, we moved. Now let's move upwards. Move upwards. Okay. We can move. We cannot just zoom in and out. Let's separate this in its own class to simplify it. Here. Let's class camera class. And let's have GLM matrix, view matrix. And let's have a constructor. And in our constructor, let's copy all of this. Right. And actually, yeah, let's copy all of this. And let's paste it in our constructor. And a view matrix. Let's have this as a view. I have to sit down. Yeah. So we will abstract it away in its own class. And I really believe that we're really close to having a camera working. I think we're really close to having it working. I'm trying to check. Okay, you can hear the audio. Fine. Okay. Now, let's look at here. Now, we are creating our view matrix. And what else we want? We want to have here actually to have the camera position, right? Like all of these should be here. Here, let's have them public. And let's delete this test. And this is initial position. Let's set it back to zeros. This is the default. And here update view, like it should be of void update view matrix. And here let's do it like this, view matrix. And here, that's it. And we can, and here let's avoid and let's have an update function with a shader. Shader program assigned int shader program. And let's actually have this. And let's camera. And in our camera, we paste it because we're updating the view matrix. Here is just it gets our view. And before that, we update the view matrix. Now, in our code, we should, when we render everything, let's create the camera here. Camera, let's create the camera. And here, let's camera update and shader program. Now we should get the same result as before. We should get the same result. Yeah. We are getting the same result. And now let's actually connect it with the process input. And let's check if let's have the camera move around with, for example, H key. Move to let me 1 second. I had to mute for a second. Okay. Move to, this should be move to now H, because I'm using the home row keys. For me, H is to left. And this is to right, up, down, and here H to the right should be L key, and upwards should be K, and here should be J. And here, instead of closing the window, we should get the camera here, a reference. camera. And here, when moving to the left, camera, we are changing the position. Oh, we are still calling it camera position. I want it to be just front. I want to change them because we already know that it's the camera. Camera, this is just the front. We're just removing this camera from here. Like this. Perfect. And now here it's now just position. It's just much more readable. And let's add let's add float camera speed. Let's set it to 10 for now. And here position, moving to the left, this should be minus equals. We are subtracting. I should be multiplying by delta time, but we're just testing here. It's not that big of an issue. And here it should be actually the x-axis. And here should be plus. Here for upwards, it should be the y, and for upwards it's minus. And here it's it's again the y, but here should be plus. And we delete. And now we should have, I think this should, like, how did this work? I think this should be like, was the reference here? Yeah. And now, okay, let's move. Yo! We're moving around, and here we should be having 50,000 objects. Like I'm moving to the right. Yeah. We have 50,000 objects. And the FPS we're running at is 160. Because we are doing 50 draw calls, not 50,000. We are just doing 50 draw calls. Look at it, man. Yo. This is so awesome, man. We can move up and down, left and right, but we don't have zoom in and out. I'll try to add this as well. We don't have textures, but it should be for another time because we're crossing 4 hours. Let's see what can we do with the camera. The camera. Oh, you know what's the issue? What might possibly be the issue is when we change that, look at how we are adding to the front. And here we are adding nothing, but what if we have to add, like here, when we change this to be like 2, the z-axis for our position to be 2 instead of 1, it's nothing. It shows nothing, it doesn't work. But what if we set it here as 2? Oh, come on, I really wanted it to work here. What if we, okay, let's bring it back as 0 and let's just move around to see, can we find anything? Moving up, nothing, left, nothing, down, nothing. Yeah, I'm moving around and I'm not seeing much. I'm not seeing much. So we can... This is really weird. Yeah, we only have zoom in and out to figure out. We only have zoom in and out to figure out. Let's see if we have something here for clip. No. Like near. It was called near. No. Let's quickly look through here if there's something for... Like it should be with the view matrix. The view. Here. Yeah, here we have this view. Camera position. Front. Yeah, look at the front. It's -1. And for us, it's not that. For us, now it's -1. It still doesn't work when we have a position of 3 Z value. Yeah, it's still the same. This is the confusing part. Camera position plus camera front. Yeah. And we need to have here for position another value. Like, no way. We have to have it. And here it should be... Oh, come on. Here should be position. And here, what's the issue? Oh, vec3. It should be vec3. Here and here should be position. What's the issue? Isn't okay. Positon. Position. Yeah. And here I also messed it up. Position. 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 Okay. Now our camera. I lost the camera. I should have them in separate files, but okay, position. Now for the for here, let's have it as 3. Still doesn't work. Why? You know what? Is it because it only works here if it's 1, right? Yeah, it only works if it's 1. It only works if it's 1. Let's see now. Camera up is the same. Camera front. Camera front -1. Yeah, it's the same. Camera position. Yeah. It's the same, kinda. Look at process input. Yeah. Okay, movement. Let's see here, view matrix. Zoom, yeah, zooming. Perfect. Yeah, but he's using the perspective. Yeah, he's using perspective and has scroll callback. He's changing the field of view. Probably. Okay, maybe in orthogonal we don't have... I'll think about it. Like, I'll leave it at this. I'll leave it like that. Let's go to showcase. Okay, now showcase. This is what we got for this stream. What we managed to do is, thank you for following the Wrapped. What we managed to do is we managed to render 50,000 blocks running at 160 FPS by batching them together and not rendering and not having 50,000 separate draw calls. And we created a camera using a view matrix, and we can move around with the camera. And you know what we can try? We can increase the blocks even more just to stress test the machine, how much blocks it can handle. Where is our... Here. In our... Yeah, we ignore the block count. Here. Now, this is 100 times 500. So let's do it times 1000. No, let's make it 500 times 1000. So this should be 500, 500,000. It should be 500,000 blocks. What? We have 500,000 blocks at 40 FPS rendering right now. And I'm scrolling downwards. Like, I cannot reach the end here, scrolling downwards. And we have a lot more to go scrolling to the left. Like, we have 500, like we have, my math should be correct. We have 500 times 1000. So 500,000 running at 40 FPS. This is it. This is our 40 FPS. And we accomplish this by batching them together. So instead of 500,000 separate draw calls, we are doing, I think 500. No, 5,000. We're doing 5,000 draw calls, I think. Because we're doing one draw call draws 1,000 rectangles. Yeah, I really wanted to have, and we created the camera. We can move around with the camera, but we cannot zoom in and out. I don't know how to zoom in and out. We have to figure it out next time. And we also added this FPS counter by just, the FPS was really simple to implement. It's just 1 divided by delta time. That's it. That's our FPS counter. It's really simple. And that's it. That's our stream. Like, I hope you had fun. Hope you have fun. Like, that's it. Thank you for watching. And we'll be ending.